Good morning, everyone. My name is Reginald Holder, and I am the Consumables Product Manager at Retreading. I will be presenting consumables used in the retreading of tires. Welcome to the first Retread Consumables webinar. Please use the chat for any questions throughout the presentation. We'll keep an eye on your messages and address them live or during the Q&A. Your mic will be disabled. At the end of the session, you will be able to unmute your mic. This will be a 30-minute session. Did you know that producing a brand new truck tire requires nearly 80 liters of crude oil, and that every one tire discarded contributes significantly to global waste? Now imagine if we could cut those numbers in half, saving resources, reducing costs, and keeping thousands of tires out of landfills each year. That's exactly what tire retreading allows us to do. Tires are the backbone of transport and logistics. Every tire, bus, or heavy vehicle relies on tires not just to move from point A to point B, but to do so safely, efficiently, and cost-effectively. However, tires are also one of the highest recurring expenses for fleet operators. When a tire wears out, replacing it with a brand new one is costly, and disposing of the old casing adds to environmental concerns. This is where tire retreading comes into play. Retreading is the process of giving worn tires a new lease of life by replacing the old tread with fresh rubber. It is widely recognized as a sustainable and economical solution, offering up to 60% savings compared to new tires, while also reducing waste and conserving raw materials. A well-retreaded tire can perform almost as reliably as a new one, but only if the process is carried out correctly and with the right materials. The success of retreading doesn't only depend on machinery or skilled operators. It relies heavily on something often overlooked: the consumables. Consumables are the heart of the retreading process. They may seem like small everyday items in a factory, but in reality, they determine whether a retreaded tire will be safe, durable, and profitable, or whether it will fail prematurely. These consumables include everything used from first inspection right through to final inspection. Each one has a specific function, from repairing damaged casings to ensuring perfect adhesion between old and new layers, to protecting the tire during curing. Without these consumables, the retreading process would be incomplete. More importantly, without quality consumables, the final product would not meet safety standards or customer expectations. In the transport industry, where tires carry heavy loads over long distances, reliability is non-negotiable. That's why understanding the role of each consumable is vital. In the presentation, we'll explore the different consumables used in tire retreading, look at their specific roles in the process, and discuss why their quality and proper application is essential. By the end, you'll see that consumables are not just materials we use up. They are the building blocks of retreading success, ensuring that every kilometer driven on a retreaded tire is safe, efficient, and cost-effective. What is the objectives of the consumables used in the tire retreading process? In the retreading process, consumables are the supporting materials used alongside the main rubber compounds to ensure the retread is durable, safe, and efficient. The objectives can be grouped as follows. Surface preparation. Ensure the buffed casing is clean, rough, and free from contaminants. Examples: cleaning solutions, solvents, rasps, brushes. Bonding and adhesion. Promote strong chemical and mechanical adhesion between the old casing and new tread rubber. Example: cement, cushion gum, bonding gum, and adhesives. Repair and reinforcement. Restore damaged areas like injuries, nail hole, sidewall cuts, before applying the new tread. Examples: repair patches, patch cement. Sealing and protection. Prevent air leaks and contamination during curing and after retread. Examples: envelope loop, wicking. Curing support. Assist in uniform pressure, air removal, and correct heat distribution during vulcanization. Examples: envelopes, inner lobes, and curing tubes. Inspection and quality assurance. Detect defects, separations, or trapped air to ensure safety of the finished tire. Examples: chalk, paints, sprays, and detector fluids. Operational efficiency. Improve handling speed of production and reduce waste in the factory. Examples: lubricants, stitching, tools, etc. In short, Consumables in tire retreading exist to clean, repair, bond, seal, cure and protect the casing so that the retread performs like a new tire in safety and mileage. Let's break down the consumables used in the different stages of tire retreading. Safety note: the operator must at all times wear protective clothing during each stage of the retreading process, available from Leadertread. Number 1. First inspection. Tire probe. To probe at cuts, penetrations, and areas of localized damage. Pliers or pinchers. To remove penetrating objects such as nails, screws, bolts, sharp pieces of steel, etc. within the tread area. Also to remove existing loose repair patches or plugs. Sharp knife. To cut away loose areas of damage or tread rubber to assist in damage assessment. Tape measure for injury measurement and repair assessment. Portable hand lamp to assist in the examination inside the casing or areas of shadow. Tire markers, marking the location and identification of injuries. Safety glasses for eye protection when removing penetrating objects, stones, glass, etc. Vacuum for the removal of debris from inside the casing. Scraper for the cleaning of the inner liner of the casing together with cleaning solution. Gloves and protective clothing to protect the operator while handling and sorting casings. Number 2. Buffing. Safety note: the operator must at all times wear safety glasses and ear protection whilst buffing. The primary purpose of the buffing operation is to remove the oxidized and the residual tread rubber from the original casing, and in doing so, to provide a suitable buffed profile and surface texture for the application of cushion gum and pre-cured tread prior to vulcanization. Before commencing the buffing operation, the condition and sharpness of the rasp blades must be checked and verified in order to achieve optimum levels of buffed texture without scorching. Buffing blades. The primary purpose of the buffing blade in the rasp hub's operation is to remove the oxidized and residual tread rubber from the original casing, and in doing so to provide a suitable buffed profile and surface texture for the application of cushion gum and pre-cured tread prior to vulcanization. Our matching guide on buffing blades is downloadable from our website, and you can also download it by scanning the QR code. Spacers. Spacers are used in between the buffing blades in the rasp hub for spacing to get the required buffing texture and for air to flow through the rasp hub for cooling the blades. A file is used for sharpening of the buffing blades, to retain the required buffing texture. We will now show you a short video on how to optimize your buffing hub.
Welcome to this step-by-step guide on packing a buffing hub with blades and spacers. This setup ensures optimal performance and efficiency. Let's get started. Begin by placing a blade first, then add a thick spacer. Continue alternating, a blade, then a thick spacer, until you have placed 5 thick spacers. Next, add 1 thin spacer. This completes the first section. Now place another blade, followed by the thin spacer. From here, continue the same alternating pattern. Thick spacer, blade, thick spacer, blade, until all the blades are in place. Once everything is packed, double-check that the blades and spacers are evenly spaced. This arrangement ensures proper contact and the best buffing results. And that's it. By following these steps, you'll have a properly packed buffing hub ready for use.
Number 3, skiving. Skiving is an essential and also the most time-consuming operation within the retreading process. The operation must be done correctly using proper techniques and suitable tools to endure the full life of the retread. It should always be remembered that poorly processed skive-out repairs lower the quality of retreading and they are difficult to identify at final inspection. Low-speed grinder used with rasps need to operate at low speeds, and a high-speed grinder used with mounted stones need to operate at high speeds. Rasps. 16 grit tungsten carbide rasp for rough work, removing rubber and steel from damaged area. 36 grit tungsten carbide rasp for fine work, removal of small amounts of rubber and to get a fine texture. Mounted stones for cutting frayed or loose steel cord ends and trimming. Rotary gouge, size 1 inch to 2 inch for removal of large amounts of rubber. Carbide cutter, ideal for preparing an injury for patch installation. Pistol grip air drill is used with carbide cutters. Encapsulated wire brush for removal of burnt or scorched rubber, texturizing, exposing steel cords without damaging, and also for cleaning. Knife used for the cutting of loose rubber. Probe used to determine injury size and for checking remaining damages. Hand wire brush, cleaning the rubber dust from buffed or skived surfaces. Number 4, tire repairing. During a tire's service life, a large range of problems can affect the actual tire structure. Some of these may be due to small penetrations with larger objects or other tire-related problems. Many conditions manifest themselves due to normal wear and tear, a missed manufacturing production fault, or plain tire abuse. Repairing is a well-tried, professional and very successful method of permanent tire refurbishment. It is the correcting of defects so that the tire can complete its full service life. In all cases, the area to be repaired will need to be cleaned and inspected in a well-lit area. Specialist tools will be used to remove all the injury, rust and damage from the tire before any final assessment can be made. The repair is completed by the vulcanization of high-quality repair materials which provide the strength, rubber finish and the tire resealing quantities. Although the tire has already been through an initial inspection procedure, the repair technician should always re-inspect for secondary damage which may have resulted or been caused by the initial problem. Patches. Leader Trade supplies patches for damages ranging from nail holes to big injuries, from mushroom plugs to sectional cure patches. The two main types of patches Leader Trade supply is number one, a dual cure patch, which are patches made from advanced tire repair materials designed to fix injuries in both radial and bias tires. Unlike conventional patches that require a specific curing method, dual cure patches are versatile. They can be applied using either chemical curing or heat and pressure. This flexibility makes them suitable for a wide range of repair situations, from small punctures to substantial injuries, ensuring strong adhesion, durability, and extended tire life. Number 2. Sectional cure patches. Leader Tread sectional cure patches are built with specialized repair materials used to restore the strength and integrity of damaged areas. In tire casings, particularly in truck, bus, and off-the-road tires. Unlike small puncture repairs, these patches are designed for larger injuries, such as cuts, tears, or impact breaks in the tread or shoulder or sidewall. They are applied to the prepared injury area on the inside of the tire and then cured under heat and pressure, bonding the patch securely to the casing. Sectional cure patches restore structural strength, prevent further damage, and extend the service life of costly tires that would otherwise be scrapped. Taper point knife, used to cut away loose pieces of rubber or old patches. Probe, used to identify the damage and determine angle, size, and depth of penetration. Vacuum for the removal of debris from inside the casing. Inner liner cleaner removes grease and other lubricants that contaminate the buffed surface during preparation. Liner scraper. The inner liner scraper is used after using the inner liner cleaner to remove contaminated debris and to clean the inner liner. Low-speed air tool is used with rasps that operate at low speeds of 3000 to 4000 rpm. High-speed air tools are used with mounted stones operating at high speeds of 30,000 to 40,000 rpm. Pistol grip air drill used with carbide burr. 6 mm carbide burr, lateral cutter for steel crown plies. Carbide long pencil 3 mm, lateral cutter for steel body plies. Mushroom stone is a round stone for skiving and crown buzz outs, cutting frayed or loose steel cord ends and trimming. Pencil stone, cut back exposed wires. Stitcher, stitch the patch from the center outwards to eliminate air trapped under the patch. Cup rasp, lightly buff the area outlined for the patch to achieve RMA3 texture. Rotary gougers, remove damaged rubber, old sectional cure or chemical cure patches. Pencil and cone rasp, cut back and trim all loose, rusted steel plies. Flat face rasp, remove damaged rubber at 45 degrees angle to expose injury to the top belt. RMA3 texture to be achieved. Encapsulated wire brush, remove scorched rubber due to overheating with high-speed air tools and texturize. Repair ruler and repair chart. Measure the length and width of the injury. Use repair chart to choose the correct size patch for the injury. You can download our patch application chart from our website, or you can scan the QR code for download. Tire marker. the marking of injury, injury type, size, and the outline of the patch before buffing of outline. Pliers or pinchers to remove penetrating objects such as nail screws, bolts, sharp pieces of steel, etc. within the tread area. Also to remove existing loose repair patches or plugs. A stencil brush is used to apply chemical or vulcanizing cement. Number 5. Cementing. The main objectives of cementing is provide necessary tackiness for filling and cushion application, protect buffed rubber surfaces and exposed steel cord ends from oxidation. Cement is a solution of unvulcanized rubber compound in a selected solvent. Cementing, by brushing or spraying, forms a thin layer of cement over the buffed surfaces. After the evaporation or drying of solvent, rubber remains over and forms a tacky thin cushion layer. This tacky rubber film significantly acts as an adhesive for rubber applications to hold casing and rubber together until curing operation. In fact, too much cement forms a thicker rubber film over the buffed surface and may have an opposite effect on bond strength after cure. There are mainly two types of black vulcanizing cement. Number 1 is a brush type, concentrated with more unvulcanized rubber and less solvent. Number 2 is a spray type, which is diluted with more solvent and less unvulcanized rubber to make it easier to spray with a spray gun. A stencil brush is used to apply the brush type black vulcanizing cement. Available in 25 liters, the Tough Tack is a spray type black vulcanizing cement. The brush type patch cement comes in 5 liters. Number 6. Filling. Fill all the skiving cavities around the tire, even to the surrounding surfaces, with a suitable bonding rubber. After skiving, where damaged rubber and cord are removed, skive out cavities and or low spots are created around the tire. Before cushion gum and tread can be applied, all of these cavities and or low spots must be filled with rubber to prevent the forming of air pockets under the tread. Filling operation can be performed in two ways. Number 1, filling with the extruder gun. Using leader tread repair rope, the extruder gun should be set at best working temperature of 80 to 85 degrees. If temperature is set too cold, the rubber will not be soft enough. It will be difficult to apply and damage to the extruder. If the temperature is set too high, scorching will start. No bonding anymore. Number 2, automatic filling. Automatic filling extruder, like example a AZ extruder, while tire rotating, automatically applies hot extruded cushion gum as well as filling skive outs. Leader tread suggests fill all the skives reaching the first belt and beyond with the extruder gun. Extruder gun. Heat and extrude repair rope for filling. Repair rope. Rubber compound used to fill all skiving activities. Heated with an extruder gun. Number 7. Building. The primary purpose of the building operation is to accurately apply the cushion gum and pre-cure tread products to the previously buffed and prepared casing. In essence, therefore, the building operation comprises of a procedure for the assembly of the renewed components, like example cushion gum and pre-cure tread products, to the prepared casing prior to vulcanization in the autoclave. A rubber mallet is used to stitch horizontally across the leading end of the tread only. Then from a distance of 30 centimeters back from the splice on the trailing end of the tread stitch towards the splice, starting with the center rib and working outwards, stitching each rib in turn with a rubber mallet. A staple gun and staples are used to keep pre-cured thread splice in place. Number 8. Enveloping. The purpose of the envelope assembly is to provide a sealed enclosure for the retreaded tire during the vulcanization process. The envelopes provide mechanical pressure and prevent the heat and pressure within the autoclave coming into direct contact with the bonding area. Envelope. Provide a sealed enclosure for the retreaded tire during the vulcanization process. Download our envelope care guide from our website or scan the QR code for download. Inner lobe. Apply chamber pressure during curing. Tube. Apply chamber pressure during curing. Flap. Apply chamber pressure during curing. Wicking, which is available in rubber and cloth. The purpose of wicking is to provide a passage or path for air displacement and evacuation during the vacuuming process. Envelope lubricant is applied preferably once a day while the envelope is still hot to prevent sticking to thread rubber. Number 9. Curing. The curing process applied to the retreading process is the culmination of all the effort and consumables used that has gone into the tire in the preceding operations. Chamber accessories available from ReaderThread is couplers and adapters. You can also download a couplers and adapters matching guide from our website, or you can scan the QR code to download. Also available is Teflon hoses and chamber door seals. Number 10. Final inspection. Final inspection is an operation to check the quality and integrity of the finished product following the completion of the retreading process. The primary purpose of final inspection operation is to determine whether or not the finished product meets the required specifications in terms of quality, appearance, and the needs of the customer. Tools used at final inspection: tire probe, pliers or pinchers, tire marker, portable fluorescent hand lamp, air angle grinder used with a sidewall finish disc. The sidewall finishing rasp disc is used for final trimming on the sidewall and shoulder area before painting. Tire paint is applied to the sidewall of the tire to improve the cosmetic appearance of the finished product following the completion of the retreading process. That concludes the presentation. Are there any questions?